to Darren Networks. This is my YouTube channel where I'll be going over Packet Tracer labs, Windows Server labs, maybe some cloud labs. Just basically my goal of this channel is to practice communicating technologies that I'm studying and I'm labbing and practicing, and basically just, improve my understanding by communicating about it on camera. So, um, right now, for today's lab in this video, what we're going to be covering is VLANs and route on a stick, also a trunk link, and that's about it. VLAN routing, inter-VLAN routing, and yeah, just going to be explaining some questions I have here, and then we'll actually go through all the configurations from the IP addressing on the PCs to creating the access VLANs, the trunk links. We'll get into the inter-VLAN routing by using the sub interfaces on router 1. We'll try some pings, figure out why certain pings might not work, and then later we'll figure out how to resolve that issue. And then at the end of the lab, all PCs should be able to ping each other and communicate. Um, so that's the overview of what we're doing here. So as you can see, this is a very small network. you know, um, for my very first lab, I didn't want to make anything too complicated or huge or, just could complicate things. So I just want to make it pretty simple. So we just have one router, two switches, um, and then a total of 4 PCs. So as you can see, we have two VLANs, VLAN 10 for the Human Resources Department, HR, and it will be using the 192.168.10.0 /24 network. And then we have the VLAN 20 for the IT department, information technology, and it will be using the 192.168.20.0 /24 network. So as you can see, for this switch, we have one HR device and we have one IT device. On this switch, same thing, one HR device, one IT device. These are the addresses. All right, so that's an overview of the topology. Now let's get into this very first question. What problem do VLANs solve? And I'll also add into it, what are VLANs? So VLAN stands for Virtual Local Area Network. And essentially what it is, to simplify it, is it creates logical broadcast domains. Okay, so physically, without a VLAN, for example, these two ports are in the same broadcast domain. But our goal by implementing VLANs is to segment those broadcast domains to where we want to have this port FA02 on switch 1 segmented to only be for VLAN 10, HR traffic. And for FA03, we want that to be IT department traffic, and the benefit of this is to reduce congestion. We don't want devices receiving traffic that they shouldn't receive. If some frames and packets that have nothing to do with this PC or have nothing to do with the IT department, when we're talking about a larger enterprise environment, this is a very small setup we have here, but we don't need that unnecessary traffic of, not having those logical broadcast domains separating the traffic by VLANs, and instead everything is just on the same, just whatever ports are on the switch, you're in the same broadcast domain. That's not what we want. That's not secure. For security reasons, you might want to have, 5 or 6 ports, and they run to sensitive devices like certain servers or security cameras. You don't want that traffic for security cameras or something like that to be mixed with the same traffic that, for example, just a few IT department PCs. There's nothing very sensitive about that to where, you know, um, it like the data needs to be as secure compared to like something like security cameras or something. So that's the point right here in this example. We just simply want to segment the traffic from human resources and IT department. We don't want their traffic mixing together, and we want everything to be more organized. So that's the point. That's the point of VLANs. That's what VLANs are. They segment broadcast domains to keep it simple. Um, so I guess I'll get into that. What is an access port? So access ports typically connect to end devices like right here, PCs, also printers, WAPs, wireless access points, um, IP phones, things like that. But when we, and the point also for access ports, they only carry traffic for one VLAN, right? So an access port, can only carry traffic for one VLAN. Whereas a trunk, the point of a trunk is typically a trunk link is going to be configured between typically switches, like for example, between switch 1 and switch 2. It's not going to be an access port, it's going to be a trunk port because the purpose of it, we want this trunk link to carry traffic for VLAN 10 and VLAN 20. So, the different VLANs can communicate across the trunk link. Um, and VLAN, trunks they carry multiple links. So that's that. Okay, so I think that pretty much covers the first three questions. Let's get into some of the configurations. We'll start with the PCs. We'll put the default gateways and the IP addressing for each PC. So let's start with that. So we'll start off with PC1. Default gateway is going to be 192.168.10.1. So that's where the human resources network default gateway is 10.1. For the IT department network, it's going to be pretty similar, but instead of .10.1, it's going to be .20.1. So for PC1, since it's in the HR department, it's going to have the 10.1 default gateway. And this is going to come into play later when we get into the sub interfaces for router 1 when we're configuring router on a stick. Okay, but that's later in the video. Right now, that's that. Okay. So we're doing static addressing. We're not doing DHCP. Maybe in another video, I might do a lab configuring DHCP, which obviously automatically configures IP addresses, whereas static you have to manually configure it. Not doing IPv6, maybe another video we could do IPv6, but IPv4, static addressing. Let's just get right into it. 168.10.10/24 is a 255.255/24 network. Alright, let's jump right into the other PCs. So this one, like I was saying, it's in the IT department and it's in VLAN 20. So the default gateway we're doing for that is 192.168.20.1. So that's going to be the default gateway. The IP address is going to be 192.168.20.10. Automatically does the subnet. Alright. Now we'll get into PC3 and PC4. Default gateway, since it's in the HR department, it's going to be 192.168.10.1. Address is 192.168.10.20. As you can see, labeled here. Automatically does the subnet. Nice. Now we have the IT department. This one, IT department, so 192.168.20.1. 192.168.20. Whoops, 20. Automatically does it. And now let's just check over everything just to be sure. PC4 20.20. So it's 24, 20.1 looks good. 10.20, 10.1 looks good, looks good. 20.10, that looks good. 20.1, ooh, oh yeah, yeah. Okay, we're good, 10.10, 255, 10.1. Looks good. Okay, so the PCs are good. Now we'll go ahead and get into the switch configurations. Okay, so enable CompT. We'll start off with creating the VLANs. So for the first one, we have VLAN 10. For the name, we're just going to do name HR just to abbreviate it. Human resources. VLAN 20, we're going to do name IT, abbreviate it. So that's it. So the VLANs are now created. Now let's assign all of the addresses. You know, these are going to be to your access ports, and these two are going to be trunk ports. Okay, so we'll start with the access ports, going to the PCs. So we'll start off with interface F02, switch port mode access, switch port access VLAN 10, since it's in the HR department, and then for interface FA0/3, we'll go ahead and do switch port mode access again, and then switch port access VLAN 20 this time. Alright, so that's it for the access ports. You can see they're orange because they're transitioning. If we skip 30 seconds, they're up. They're just going to through the spanning tree protocol process. Alright, so now we'll do the trunk links. I'll start off with G01, G01, switch port mode trunk. Then we'll get into let's allow the VLAN switch port trunk, allow VLAN 10, 20. Then we'll do FA01 switch port mode trunk. Switch port trunk, allow VLAN 10, 20. Alright, so that's it for switch 1. Now we'll get into switch 2. So this one we just have one interface. So that's 1. Switch port mode trunk. Switch port allow VLANs 10, 20. I forgot to put trunk. Oops. There we go. So guys, remember to put trunk before allow. Alright, so allow VLANs. Okay, cool. So make sure that link comes up. Nice. Okay, now we'll get into the access ports. Interface FA02. Oh, no, actually, let's create the VLANs. VLAN 10, name HR. VLAN 20, name IT. Whoops. Thought I clicked enter. Name IT. Huh. Yeah, should be separate commands. Okay, now we have interface FA0/3, switch port mode access. Oh wait, I didn't do, well, I gotta go back to FA02 actually. Switch port mode access VLAN 20. Okay, now we'll go back to FA02. I forgot to do that. Switch port mode access. Switch port access VLAN 10. This is an HR PC. Make sure those come up. Nice, nice. Okay, so configure the PCs, configure the switches. Now, what we're going to test right here, you see I have a question. Why can't different VLANs communicate? Let's test that. So as you can see here, I'm going on an IT department PC4, and I'm going to go ahead and try to ping PC1, which is in a different VLAN. It's in the HR VLAN 10, and let's see what happens. Ping 192.168.10.10. Let's see what happens. I'm gonna skip ahead 30 seconds. So the pings didn't go through. Why is that? So the reason why PC4 here, that's in the IT department, cannot ping PC1, which is in the HR department, is because they're segmented, right? Like I talked about at the beginning of the video, the purpose of VLANs, you know, without doing more to it, is completely segmenting those ports, right? So, or those VLANs, you know. So right now, VLAN 10 and VLAN 20, they're completely segmented. They cannot communicate. A device in the IT department cannot communicate to the HR department. No way, shape, or form. You know, and the only way, there's a couple ways that we can enable this communication for the pings to go through, and that's by configuring something called Inter-VLAN Routing. So Inter-VLAN Routing is what enables devices in different VLANs, although they're logically separated, to be able to communicate with each other by, you know, you can use, in this example, we're using a router with router on a stick, but you can also use a multi-layer layer 3 switch as well. But in this example, we're going to be using a router, and on a router, you know, we're going to create a trunk link, and we're going to create sub interfaces with the PC's default gateway, so they can be able to communicate with each other. Oh, just to show you, right now, as you can see, within the VLAN, PC4 can actually ping. You know, it pings with no problem another PC in its specific VLAN. So any device that is in this VLAN, in this subnet, it can ping. But it can't ping outside of its network and its VLAN, right? So we're going to fix both of those issues by configuring a router on a stick. Something I do want to do on both switches before we get into the configuration is I just want to do some show commands. So let's do show VLAN brief, and we'll also do show interface trunk. So as you can see, this is our VLAN configurations. On switch 1, you can see FA02. Let's connect to the HR department, HR VLAN. FA03, IT department. These are default VLANs, 1002, 1005, VLAN 1, default native VLAN. Oh, something that I'll touch on, as you can see, when I configured the trunk link between switch 1 and switch 2, I didn't have to specify that it was 802.1q encapsulation, The reason for that is because certain model switches, um, their only option, they're like I believe most modern switches only support 802.1q. So this is an example of here in Packet Tracer, the model switch that I'm using here, it automatically just supports 802.1q. I believe it automatically does it because it doesn't support IEEE ISL. So it doesn't support ISL, so you don't have to specify. Whereas later when we get into configuring a router, you actually do have to specify um, what encapsulation protocol you want to use. Is it .1q or ISL? You know, you have to specify that. But for the model switches we have, we didn't have to specify that. So you can see trunking, default native VLAN 1. You can see that allow VLANs that we did. Did I do allow VLANs on this one? But that's the show commands there. Oh yes, I did. Okay. So we'll just do the same thing, do show VLAN brief. Oh, actually, let me go back, and since we're done here, I just want to copy my running config so I don't lose it if the PC shuts off or, you know, something happens. So I want to make sure that's saved to the memory. Now we'll get into do show VLAN brief, do show interface trunk. Alright, pretty much same thing that we just seen there. Same exact thing, encapsulation 802.1q, allow VLANs. You see the ports 02, HR, FA03, IT. So same things. Alright, now let's get into, so we kind of touched on verifying, you know, switch 1, switch 2. We did some pings to finish off the verifying. We're going to verify that after we config router on a stick, that we actually can ping from different VLANs. So we're going to try again pinging from PC4 to PC1. We're going to try that again after we configure Inter-VLAN routing. So let's get right into that. So we'll start off with just enabling interface G000. We'll do a no shut that enables it, and then we'll create our first sub interface, which is going to be interface dot 10 for VLAN 10 in the HR department. So it automatically enables. But for the router, like I was saying earlier about the switches, it automatically knows that it's 802.1q. But for this model router, it supports ISO. So you actually do have to specify that we want to use, as you can see, if I do a help command, you know, for the encapsulation, you could do .1q, you could do IEEE 802.1q. I thought it had ISO option, but you can see that there's different options, right? We want to do the .1q, and then you do another help command, and then you have to specify the VLAN ID. So for this one, since it's for the HR department, we're going to do the VLAN ID is going to be 10. So encapsulation.1q.10. Now we can do the IP address. If we try to do the IP address before setting the .1q, we would have got an error message. I'll actually before we do the next one, I'll actually show the error just so you guys can see. IP address, what is it? 192. It's gonna be the default gateway that we set earlier on the PC. So 10.1 and then subnet 255.0. Alright, so like I was saying, let's see what will happen if we try to, for VLAN 20, let's see what will happen if we try to do the IP addressing before we set the encapsulation. 20.1, 255, 255.0. As you can see, we get an error message. So as you can see, it says configuring IP routing on a LAN sub interface is only allowed if that sub interface is already configured as part of an IEEE 802.1.10 or IEEE 802.1q or ISL VLAN. So you have to specify on this model router, you have to specify which encapsulation protocol you want to use. So we want to use .1q, so that's why we have to specify that encapsulation .1q, and then the VLAN ID this time is going to be 20 for VLAN 20. Now we could do the IP address 20.1 255. All right, so oh, I think I forgot one thing. I think on interface G00 we need to do switch port. Oh wait, no. Never mind. That's where the switch is. I think we're good. Because we have encapsulation. I think we're good. So now let's try the pings again. Before that, I'll just do a quick do show IM3. So you can see the interfaces we created. And then we'll just copy that. So we should be done here, I believe. Now let's try again. So as you can see, if we just try to ping the same IT device, it's gonna work just like it did before. But let's see here if now we could talk in different VLANs. Let's see. All right, so you can see that we sent 4 ICMP messages. That's what ping uses. And we received 3 and we lost 1. The reason why we lost 1 is simply because of ARP, Address Resolution Protocol. The first ping before 2 devices ever communicate with each other, you're going to lose 1 packet because, the ARP process, they have to send out, hey, what device has this MAC address, the whole process of ARP, right? So that's why 1 ping was lost, but we do it again. This time it's 4 for 4. So that's just because of ARP. But as you can see here, in this lab, we configure VLANs, we configure the trunk link, router on a stick, Inter-VLAN routing, IP addressing on the PCs, access ports, trunk port, the VLANs, name the VLANs, router on a stick, configure the sub interfaces. And this was all because, we wanted to segment the traffic, but then we wanted different PCs and different VLANs to be able to communicate if they wanted to, and that's why we needed either a multi-layer switch, layer 3 switch, or a router with router on a stick. We did router on a stick here. So that's it. We verified everything works with the ping and the show commands. We copied everything to the running startup config. We explained everything, went over all of these questions. So that's it. That's it for my first video. Many more to come. Pretty much the whole purpose of this is to study technologies, practice labbing, but also I wanted to add the element of let me record myself doing it and communicating about it, because I think that's what really, that's just a different level that can easily be skipped, right? Like you could think you know something, but can you really explain it? Can you really walk through what you're doing? Can you give a tutorial? Um, you know, and let me know, give me some feedback if I said anything wrong or if I explained anything incorrectly. Give me some feedback or some constructive criticism. I could really use it, because at the end of the day, the purpose of me doing these labs is not to come across as an expert or anything like that. It's simply to learn. I think that knowing these labs, but adding in the element of recording myself and trying to communicate about it and explain what I'm doing and answer questions like this and doing the commands live and some commands I might mess up, and then you guys see the mistakes I made. This is no edits, it's just raw, unfiltered. Um, I feel like that's going to help me learn, and it's going to develop me as a professional, you know? So I just plan on continuing to be consistent with labs and projects, and, do a write up on GitHub. I'm going to write this up, screenshots, post everything to GitHub, but then also I'm recording myself so I could post a YouTube video, so you guys could see me on camera, see me talking, see me doing everything live. And I just think that's going to help me. That's going to help with my communication, something I want to get better at. You know, I have certifications, I have education, but uh, you have to practice. The only way to get better at communicating in general, and specifically, I'm trying to get better at communicating about technology, so I can better portray the knowledge that I have by, recording myself doing it. And that's pretty much it. So, you know, more labs to come. Not sure what the next lab will be, but probably at least the next few labs, I'm going to focus on networking labs through Packet Tracer. But I might get into, you know, some virtual machines like Windows Server, um, Active Directory, things like that. I'll also get into that too. But for now, that's today's lab, and you know, uh, let me know, like, you guys, just give me any feedback, any thoughts, any comments. You can leave them on my LinkedIn or my YouTube channel. I'll be posting it on both. Um, and yeah, I just want to keep learning, keep growing in this field. Um, and that's about it. That's about it. So I'll catch you guys in the next video. It's my YouTube channel, Darren Network. So thank you for watching.